Welcome to week 3, lecture 2, production and cost in the short run. In this lecture, we are going to focus on the use of one input to produce a given level of outputs. We're going to hold all the other factors of production constant like capital, land. We're going to hold them constants, and then we'll vary one input, which is labor. So let's go ahead and get started. Production of goods and services typically involves a complete transformation of inputs into finished products. Now, if you are producing lemonade, you need all the ingredients to produce lemonade. And then you also need some efforts to produce lemonade. So physical efforts, human effort to produce lemonade. So all those factors combine together to produce maybe a gallon of lemonade or maybe 5 or 6 gallons of lemonade. The same applies to an agricultural farmer who wants to produce, let's say, sugarcane. So before a venture into the production of sugarcane, he needs to have the land available. He also needs to have the manpower to till the land. Then some other needs to have capital to provide seedlings. Buy the seedlings so that he can start his farming business. So all these resources put together result in the production of the finished products. So here we are looking at how raw materials are transformed, or we are looking at the complete transformation of inputs, that is raw materials, into finished products. So we're looking at the farmer here in his seedlings to carry on with his sugarcane business. So you also need some manpower to do to carry on with the sugarcane business. So the complete transformation of the raw material as well as the labor used to produce the finished products, the sugarcane, is what is referred to as production. So later on we're gonna see how different production functions are represented, like the Cobb-Douglas production function, and how we also try to obtain derive the returns to scale. So for now, our main focus here is on the production of a particular good using a single input, which is labor. Now, we talked about in consumer behavior, we talked about the decision to consume a particular good subject to maybe the income of the consumer. But here, we are looking at a producing unit in the economy that uses labor and other factors of production to produce goods and services. So specifically, we are looking at the farms. So they use labor and then other factors of production to produce a given level of output. Now, the inputs that are used in the production of output are referred to as the resources. So inputs comprises labor, raw material, capital equipment, and the farm combine these raw materials or these inputs with the appropriate technology to produce a given level of outputs. So as you can see in this small tutor diagram, we have inputs being transformed into outputs through appropriate production technology. Now we'll move on to the production function. Now, this is a mathematical representation that shows the maximum quantity of outputs a farm can produce given the quantities of inputs and appropriate technology. For instance, we have a corn farmer's production function with only one input. It's giving us Q equals A of FL, where Q is the output of corn produced, A is the level of technology, and L is the number of workers on the farm. So you might need maybe 1,000 workers to produce in the corn field, to produce corn. You also need to use some capital equipment to till the land, and you also need the seedlings. So they use capital to buy seeds. So in this case, we are only looking at labor, assuming that all the other factors are held constant. It's like capital, land, these are all held constants. So we only have labor as main inputs in the production process. Now let's look at a typical production function here. Looking at this diagram, we see that we have points on the production function. So points on the production function are referred to as technically efficient points of production, and then points below the production function are referred to as technically inefficient points of production. So why do we say those points on the curve are technically efficient? Because for those points on the curve, the farm or the producer produces the maximum outputs with only the use of limited resources, less inputs. Use less inputs to produce the good. So the farm here uses less inputs to produce the good. So if the farm can use less inputs to produce the maximum amount of outputs, there we say the farm is technically efficient. So he's using his inputs efficiently in the production of outputs. Now, so why do we say it is technically inefficient? It is because the farm is technically efficient here because given it, the appropriate technology, he has all the technology at his disposal. He has the needed amount of output to produce at point A and point B. But he's not producing at point A and point B, probably because of maybe mismanagement or maybe some other factors. So this all resulted in the production of output that is below what he could produce, what the farm is capable of producing. So at this point C, D, and E, the farm could have done more. It could have done more because it's capable of producing. He has the appropriate technology to produce at point A and B. But because of some factors, he's not producing at point A and B. So in this case, we say the farm is technically efficient. So the level of production here or output here is not produced efficiently. In other words, maybe some other factors, you have a lot of resources lying idle, so farm is not able to use these resources efficiently to produce the given level of output. That is the output that it could produce, is capable of producing. A farm's production set is given by all points on the production function and below it. Now, so all points on the production function and below it, that's the production set. Producer. Now, it cannot produce beyond point A and B in the previous slide. Now, you see points A and B are on top of the curve, right? So the farm cannot produce beyond point A and B because it does not have the capacity to do that. It is unable to do that. It does not have the resources to produce beyond point A. So, but all the points on the production production function and below it, these are all possible points of production. In other words, these are points in the production sets of the consumer, of the producer. These are all production sets of the producer. So like A and B, we say the farm is producing outputs efficiently. So point A and B are technically efficient. The farm's production set is the set of all technically feasible combination of inputs for producing a given level of outputs. Now, what is technically efficient? Or what is technical efficiency? So this refers to the set of points in the production set at which the farm is producing as much output as it possibly can, given the amount of labor inputs employed in the production of the good service. A technically efficient production process is one that uses less inputs to produce a large amount of output. So, as we see on the previous slide, we notice that at point A and B, the producer produces the maximum level of output by using less amount of inputs to produce that volume output. So if that is the case, then we say the farm is technically efficient. If we are to produce at point C, D, and E, then we say the farm is technically inefficient because it's producing below its capacity. It's not producing the same amount that it could produce because it has the ability to produce at point A, but because it can't produce at point A, we say it's technically inefficient. So we see all the points C, D, and E. Say the farm is technically inefficient because it is not producing as much output as it could labor on appropriate technology. Now let's look at labor requirement, the labor requirement function here. Now we use the labor requirement function to determine how much labor is required, or what is the labor requirement, to produce a given level of output. Let's say, for example, the farm wants to produce like maybe 10 tons of rice. So we want to know the amount of workers that it needs to produce produce 10 tons of rice. So the only way we're going to do this one is to obtain the inverse of the production function. So if we obtain the inverse of the production function and then plug in the values of the outputs that the farm is supposed to produce, then if we solve, we'll be able to know how many workers we need to produce a given level of outputs. Let's say, for example, we want this farm to produce 30 units, maybe 30 tons of rice. Now we look at the production function. Let's say the production function is giving us what? Q equals to L squared. So, in order to find the labor requirement here, what we need to do is to express the labor as a function of the outputs. So in this case, instead of having Q equals to L squared, we're going to have L equals the square root of Q. So if we plug in Q which is equal to 30, take the square root of 30, then it's going to be something around 5 point something, 5.5 or 5.8. So approximately, this farm needs about 5 workers to produce the 30 tons of rice. So let's look at this simple exercise here. Suppose the farm wishes to produce an output of 27 units. What is the labor requirement for this farm if the production function is given as Q equals to Q? So what we need to do here is we express L in terms of the outputs. Instead of having outputs in terms of labor, we now have labor in terms of outputs. So if we do that, the labor variable is going to be a function of what? The cube root of outputs. Now all we need to do is to plug in the value 27. In place of Q, write 27 there. So we take the cube root of 7, which is 3. So this means that to produce 27 units of outputs, the farm will need to employ, not top, right? The farm will need to employ, not TOP, to employ at least 3 workers. So it needs to employ 3 workers to produce 27 units of output. Now this brings us to the definition of the labor requirement function. It is simply a function that represents the minimum amount of labor needed to produce a given level of output. Now the word minimum there should be noted. It is just the minimum amount of labor that is required to produce a given level of outputs. So the farm may need more, but that is the minimum amount that it needs. So it may need more than that minimum amount to produce a given level of outputs. Okay? Now let's look at the typical production function with a single input. Here we say production output is just a function of labor. So for all production with a single input, they are referred to as a total product. So here we have only labor as the primary input of production. So factors like capital and these are all not factored in to this particular equation. They are not included in this equation. So we assume that those factors, production, are held constant. So the only factor that varies in this particular case is labor. So now let's look at production function with a single input. We're looking at a total product curve for a semiconductor producer. Now, if we look at the graph here, notice that the output is on the vertical axis and the labor is on the horizontal axis. Now, the total product curve is increasing at first, rises up to a point and then declines, reaches a maximum and then declines. Now, if we look at the first part here, where no labor is used. So if the farm decides not to use any labor or zero amount of labor, so it's not going to produce anything. But when it decides to employ like 6 workers, maybe 6 to maybe between 0 and 12 workers, right? So the farm experiences increasing marginal returns to labor. So that is to say, for every additional unit of labor that is employed, the outputs increases at an increasing rate. The output increases at an increasing rate. So as you can see in the graph, the total product curve is convex around that particular region. So over the range where there is increasing marginal returns to labor, the total product curve is convex. Sorry. That is between 0, L equals to 0, L equals to 12. Now think about this one. So when there are increasing marginal returns to labor, right? So an increase in the quantity of labor increases total output at an increasing rate. So think of this as like this. Now the increase in marginal returns are usually thought to occur because of the gains from specialization of labor. Now, the increase in marginal returns to labor here occur because of the gains from specialization of labor. So that is why we see output increasing at an increasing rate when additional units of labor is employed. Because the farm experiences gains from specialization of labor. So take for example, you have a small industry where you have so many workers have to perform a lot of tasks or multiple tasks. For instance, you have a worker who might be responsible for moving raw materials within the plant. And you have another farm who is operating the machine. You have the same farm, maybe, okay, same worker who is also operating the machine, right? You have one particular worker who is responsible for moving raw materials within the plant, and then you have the same worker who's also responsible for operating the machine. And at the same time, he is responsible for inspecting the finished goods once they are produced. So here, this particular worker is performing 3 tasks. Is moving the raw materials within the plant, is also responsible for operating the machines. And then number 3, he inspects the product, the finished product, once they have been produced. So what happens here is there is no specialization, right? So he does all the 3 types of activities. He is not specialized in any, right? So assuming that this particular industry farm has only 1 employee, right, who is moving the materials within the plant, at the same time is operating the machines, and is also inspecting all the products after they have been produced. Now, all these tasks could have been done by other employees or other workers. Now, if the farm decides to employ more workers, right? So as he employs more workers, as more workers are added, they can specialize. Now, some of the workers will be responsible for only moving the raw materials. That is only their job. And so they can do it efficiently. Right? And then you have other sets of workers that are responsible for operating the machines. They are not going to move the raw materials. They only operate the machines. So they do the type of job that they can do best. That is, they specialize on a particular activity. And then you have others who specialize in inspecting or doing inspection or quality control. Right? So as a matter of fact, when you look at this, specialization enhances the marginal productivity of workers because it allows them to concentrate on the task at which they are most productive. So specialization here enhances the marginal productivity of the workers because it allows them to concentrate on the activity at which they are most efficient or most productive. So rather than 1 or maybe 2 doing like multiple tasks, you have only a few doing now 1 particular task for which they can do efficiently or for which they can produce their best. So if that occurs here, now we see production increasing at an increasing rate. That is, we have increasing marginal returns to labor. So that is the first part of this particular curve. Now let's look at the next part here. That is when he decides to employ between 12 and 24 workers. So what is going to happen here? Output is going to increase, but it is going to increase at a decreasing rate. It is not going to increase at an increasing rate. So as you observe, looking at the graph here, you see that for that particular region, the total product curve is concave. It is not convex. Meaning that the output is increasing at a decreasing rate as the farm decides to employ more workers. So as it adds more additional worker or more employees to the business or to the production process, the output is going to increase, but at a decreasing rate. So now you will tend to ask yourself the question, what is causing this one? So that is the big question. Why is output increasing at a decreasing rate? Is it because the farm has exhausted all its ability to increase labor productivity or not? Certainly yes. So the reason why output is increasing at a decreasing rate here is because the farm has exhausted its ability to increase the labor productivity through the specialization of workers. So once that has been exhausted, diminishing marginal returns to labor, that is the variable input, will set in. It will set in when the farm has exhausted its ability to increase labor productivity through the specialization of the workers. When that occurs, between labor equals to 12 and labor equals to 24, then diminishing marginal returns sets in. And in that case, outputs or total products will be increasing, but at a decreasing rate. So when we say it is increasing at a decreasing rate, it is increasing sluggishly. It is not increasing rapidly. The rate of increase here is not rapid as before, when the farm has not exhausted its ability to increase the labor productivity of its workers. It has not exhausted its labor productivity of its workers. Now let's look at the other region here, the diminishing total returns, when the labor is more than 24, L is more than 24. So when the quantity of labor exceeds 24, any increase in the quantity of labor will result in a decrease in the total output. So what do we say here? You see the total product curve declining, right? It is falling after 24, L equals to 24. So beyond L equals to 24, the total product curve is falling. So as the farm increases labor, as the farm increases the quantity of labor, the total output decreases. So in this particular case, we say that diminishing total returns to labor are setting. So diminishing total returns to labor has set in because output is increasing, it's not increasing, sorry. output is decreasing as more labor is employed. So when there is diminishing total returns to labor, an increase in the quantity of labor decreases the total output. Diminishing total returns occur because of the fixed size of the fabricating plant. If the quantity of labor used becomes too large, what will happen? Workers don't have enough space to work effectively. Now, so beyond 24, that is the maximum that the farm needs to produce, right? So beyond 24, you have a lot of workers lying idle. They are idle. They have nothing to do. So what happens here? Total product is going to decline. So the farm is not operating efficiently here. It is not operating efficiently because there are a lot of idle resources. What are these resources? Labor. So diminishing marginal total returns to labor set in when this occurs. When the farm has a lot of idle resources, and so in that case, you have output declining for every additional labor input that is employed. So there are three things that you need to note here. The first thing to note is the region where the total product is increasing at an increasing rate, right? Where total product is increasing at an increasing rate. And for that particular region, the farm has not exhausted its ability to increase the labor productivity of worker through specialization. So the farm has the ability to increase the labor productivity of workers through specialization. Now, because you have so many workers having different types of skills, specializing in different activities, we expect production to increase at an increasing rate in this particular regard. We don't have a situation where few employees are doing multiple tasks to produce a given level of output. So this occurs in the first region between L equals to 0 and L equals to 12. But as soon as the farm employs the 12th worker, if it decides to employ maybe the 13th worker, then diminishing marginal returns to labor will set in. So here, even though output will be increasing at an increasing rate, even though output will be increasing, but it is increasing at a decreasing rate. It is no longer increasing at an increasing rate. It is no longer increasing rapidly here. The reason why it is not increasing rapidly is because diminishing marginal returns to labor are setting. The farm has exhausted its ability to increase the labor productivity of the workers through specialization of the workers. So it is no longer able to increase the labor productivity of its workers through specialization. So that is why output in this region is increasing at a decreasing rate. Now, beyond L equals to 24, we notice that the total product is decreasing, is declining. It is declining because diminishing total returns to labor are setting. you have a lot of workers who are lying idle. You have some plants are not being operated in the first place because you have so many idle resources. So when that occurs, output will not be increasing in this case. It will be decreasing. So that's why you see the curve declining after L equals to 24. So these are the three things that you need to note. First point, because of increased specialization, output is going to be increasing at an increasing rate. When the farm decides to add more workers, because the additional worker will now be able to specialize, do different activities to increase labor productivity. And because of an increase in labor productivity, we realize that this will lead to what? An increase in outputs. Right? Now, beyond L equals to 12, see there is what? Diminishing marginal returns to labor. So here, the farm has exhausted its ability to increase the labor productivity of workers through specialization. And because of that, we have output increasing, but at a decreasing rate. It is increasing at a decreasing rate. That is, it is increasing sluggishly. So it reaches a point, L equals to 24. The maximum point beyond that, output is declining because diminishing my total return. This is the last point is not diminishing marginal returns now, but diminishing total returns. So to labor. So output is declining because you have a lot of idle workers. So these ones are not producing. They are not productive. So you have output declining as a result. Now, these are the points that you need to note, right? 4 points, right? When he's not using any labor, right? He's definitely not producing anything. Between L equals to 0 and L equals to 12, outputs will be increasing with additional units of labor at an increasing rate. Right? So why? Because of what? Increasing marginal returns to labor over this range. Right? So this occur because of what? Gains from specialization of labor. Now you have many workers specializing on different activities. So they are now performing the duties for which they can perform best. So everybody is doing what is able to do best. So in that particular case, productivity will rise. Right? So now beyond L equals to 12, but below L equals to 24, we see that even though production is increasing, output is increasing, but it is increasing at a decreasing rate, right? So, and why is that? Because of diminishing marginal returns to labor, right? So the farm has exhausted all its ability to increase labor productivity through specialization of its workers. So because he has exhausted that, so you notice that the output is going to fall. It's going to increase, but it is increasing at a decreasing rate, right? Now, over the beyond the L equals 24, you see that output is if you increase the amount of labor, right, you get a decline in overall output. So output is falling even though the farm is employing more workers, but output is falling because you have a lot of people, most of these employees who are idle. You know, there is not enough space, maybe in the company, enough space for all those excess workers to work. So what is going to happen? You will see most of them just being idle. They have nothing to do, right? Now, let's say, well, for example, you go to Walmart, you see a lot of people there. You see those people are saying, "Welcome, good afternoon, welcome to Walmart." Some of those people, it's possible that they are not productive. You know, they are just there. You know, welcome to Walmart. Go there, say, "Welcome to Walmart." So that's all they do. So they are not actually producing. So this is what happens when a farm decides to employ more workers. So you will have some workers who will just be doing greetings, who will be just saying, "Oh, welcome to Walmart, welcome to Walmart," which adds no value, to the total output. So this is what happens. Output is increasing, the output is decreasing. It is not increasing, it is decreasing, even though the amount of employees, the amount of workers is increasing, even though the farm is employing more workers, but it is it is employing more workers, but the output of the company or the output of the farm is decreasing as more workers are being employed. So this is referred to as diminishing total returns to labor. This is referred to as diminishing total returns to labor. Now let's move on to marginal and average product of labor. So there are two basic measures of productivity um, that can be obtained from the total production function. Now we see that the average product of labor, which is APL, is the amount of output per unit of labor employed. That is, APL is equal to total product over quantity of labor, Q over L. So later on in the lecture, we are going to look at how this particular measure of productivity is used to measure the productivity of a particular function. Now, you see, in most of the tabloids, when you hear of US productivity being compared with other countries, we are looking at a measure of the average productivity. That is the productivity per worker. The productivity per worker, right? So the marginal product of labor refers to the rate at which total product changes as additional units of labor is employed. So mathematically, the marginal product of labor is just the change in outputs divided by the change in labor inputs. So in the concept of derivatives, we say the marginal product of labor is the Q, the L. Is the Q, the L. Now let's look at a typical total product, marginal revenue, and average product of labor schedule. Now, if we look at this table, we notice that when zero amount of labor is employed, nothing is produced, and the marginal product and average product is just zero. Now let's take a look at a situation where the farm decides to employ 6 workers, right? So if it decides to employ 6 workers, what will happen here? You will see total product increasing, right? It increases from 0 to 30, right? And then when he employs more workers, up to 12, what do you notice here? It increases rapidly again to 96, right? So you notice that here, with every additional worker, the total product is going to increase at an increasing rate. So as I explained earlier, this occurs because you have a lot of these new employees or these workers that are added into the production process. These new employees specializes in different activities. So because the farm is able to increase the labor productivity of the workers through specialization, so you expect the output to increase at an increasing rate here. But it's beyond 12 employees. You notice that even though the output is increasing, but it is increasing at a decreasing rate. You see the rate of increase there from 162 to 192 is a little bit smaller. It's like a difference of 30, right? So you see output is increasing, but at a decreasing rate. And so beyond 24 workers, the output is declining. So that is what? The region of diminishing total returns to labor. You have a lot of workers who are left idle because when you employ more workers, increase more workers, and if the workers exceed the capacity that you can handle, you will notice that some workers are just idle. They have nothing to do. You know, like in Walmart, you see some people, they don't have nothing to do. They'll just go fold one particular clothes and then put that one. You know, it's because some of those, they don't have anything to do. You know, they don't have any value to the total products. So that is why you see the output declining here. It's diminishing. It is not increasing. So the marginal product here is just the difference between the total product and the total product over the total over the labor, the difference between labor. So now we say labor here is 6 minus 0, which is just 6, and then output is 30 minus 0, which is 30. 30 over 6, that gives us 5, right? So you notice also that here, what happens is a marginal product is the first measure that attains a maximum. It is the first measure that attains a maximum. It attains a maximum after the 12th worker, right? And then up to the 18th worker. It reaches that maximum and then declines. Now you notice that at a point where you have 24 here, right? So you see that the marginal product of labor is 5, right? It goes down to 5 up to minus 7 and then minus 13. Now, if we look at the average product here, right? The average product is the next curve that attains a maximum. It attains a maximum at L equals to 18, right? So at L equals to 18, the average product of labor is just 9, and then it declines hereafter. So as a matter of fact, the average product, the marginal product, is going to cut the average product at the maximum point of the average product. So this is just an example of the curve. You see that at point A, the average product is at the maximum, and then here you have the average product is decreasing, Because it is decreasing, the marginal product of labor is less than the average product. So over the range where the average product is decreasing, right, is declining, the marginal product is below the average product of labor. And over the region where the average product is increasing, the marginal product is above the average product of labor. So this is why we say these curves are all U-shaped. They are all U-shaped, right? Because over the range where the average product is increasing, the marginal product curve is above the average product curve. And over the range where the average product is decreasing, the marginal product curve is below the average product curve. So at a point where average product curve attains a maximum, the marginal product curve cuts the average product curve. So it is possible that if that happens, all of those curves are U-shaped, right? So the marginal product curve cuts the x-axis at L equals to 24. At L equals to 24, marginal product curve, marginal product is equals to 6.